Okay, and as we build our build our skills towards being able to solve systems of equations using matrices, we need to learn about two things today: determinants and inverses. We're going to stick to 2 by 2 matrices, by the way, for both of these things and for solving equations. Bigger than that, we would definitely want to use a graphing calculator for. A determinant of a matrix lets us know if an inverse is possible. You need to build the determinant. You need the determinant to build the inverse, and you also know if it's not going to exist. If the determinant is 0, then it's not possible to make an inverse. All right, how do you find the determinant? Well, you do 2 multiplication problems and subtract the answers. First, you do the downward diagonal, a times d, and then you do the upwards diagonal, and then you subtract those 2 values. All right, so here, the downwards diagonal, 8 times negative 2, 4 times negative 2 is 8. The upwards diagonal, negative 3 times 10 is negative 30. So I do negative 8 minus negative 30. So that changes to plus. So 22. The determinant would be 22. Okay. Or here's another one. Downward diagonal. 1/2 times 8 is 4. Upwards diagonal. Negative 4 times negative 1 is 4. So if I subtract 4 minus 4 equals 0. So no inverse will be possible. Okay. So what do we do with this? Stay tuned. Alrighty, an inverse matrix. An inverse matrix is necessary to solving systems of equations. The inverse matrix is a way to cancel out the elements in a matrix, leaving just 1, 0, 0, 1. And if you think about how multiplication works, and if the variables are right next to them, then that would mean 1 would go with the x, 0 would go with the y, so that would just mean x. And for the bottom row, 0 would go with the x, 1 would go with the y, so that would just be y. X equals y equals. It's basically causes the matrix to vanish, same as we add to undo subtract, or we divide to undo multiply. We do an inverse to undo a matrix. It's a 3-step process. First, well, 4, I guess. You find the determinant. If long as the determinant is not 0, you go ahead and take the next steps. Notice A and D here are that first downward diagonal. You have to switch the 2 numbers. You have to move them. A goes to the D, D goes to the A. B and C, the upwards diagonal. Those, you leave where they are, but you change their signs. If they're positive, they become negative. If they're negative, they become positive. And then you make a fraction out of your determinant. 1 divided by whatever the determinant was. And you're going to multiply that, so distribute that. So here we go. The downward diagonal gets me 0. The upward diagonal gets me negative 20. So 0 minus negative 20 is 20. Remember, minus a negative changes to plus, right? All right, so I'm going to have to do 1 over 20 times my new switched around matrix. So A and D switch spots. The 3 goes to the bottom right. The 0 comes up to the top. The 4 and the 5 change signs. So 4 becomes negative 4. Negative 5 becomes positive 5. And then I distribute. Now that seems scarier than it is, because you're just going to want to leave them in fraction form. remember, all of these numbers that don't have any fractions have ones on the bottom. So if I just think of them all having invisible little ones here, it actually is really easy to multiply, just messy to write. I have to do 1 times 0 over 20. 20 times 1. Beside it, I have to do 1 times negative 4. I'll get negative 4. And 20 times 1, which is 20. On the bottom row, I have to do 1 times 5, which is 5. And 20 times 1, which is 20. And 3 times 1, which is 3. And 20 times 1, which is 20. That is my inverse matrix. If you wanted to do 0 over 20 and write 0 instead, you're welcome to do that. Okay, here's one more. The downward diagonal gives me negative 12. The upward diagonal gives me negative 3. So negative 12 minus negative 3. That changes to add, so that's negative 9. So I have to do, better draw a line here, there we go. 1 over negative 9 times the negative 2 and the 6 trade places. The 3 and the negative 1 change signs. So negative 3, positive 1. And then we distribute. So remember, you can think of these as all having 1s on the bottom. These numbers just multiply with the top, the 1, not the negative 9. So we're going to end up with 6 over negative 9, negative 3 over negative 9. You may want to change that to just positive, because negative divided by negative would cancel out. I'm having a big enough challenge even getting it to right over here. 1 over negative 9. And negative 2 over negative 9. Again, you might want to change that to positive, because negative divided by negative turns positive. But other than that, that's our inverse. And so let me just cancel those up. And we would be able to use that in another day to solve.